Imagine you're looking at a triangle with no right angles. This is an oblique triangle. Understanding it requires knowing some key configurations to apply mathematical rules effectively. There are three setups where you can use the law of sines. These are ASA, SSA, and SAA. Each requires knowing at least one angle and the side opposite it to begin solving. For the ASA configuration, you know two angles and the side between them. This scenario is straightforward, as it directly leads into using the law of sines. In the SSA setup, you have two sides and an angle that is not between them. This can be a bit trickier, since it might not always provide a unique solution. SAA is when you know one side, followed by two angles. It's a clear path to finding all unknowns using the law of sines. Starting with one full fraction and half of another is your first step, unless it's an ASA triangle. You'll find this approach helps in simplifying your calculations. When two angles are known, finding the third is just a subtraction from 180 degrees. This helps in completing the angle measurements of the triangle. Always prefer using original data over computed data to avoid errors in rounding. This ensures accuracy in your mathematical findings. Suppose you only know three elements of a triangle. They must be specific types to solve the triangle using the law of sines, AAS, ASA, or sometimes AS. Let's apply this. How do you find a missing angle when you are given two angles and a side? Use the sum of angles in a triangle and subtract from 180. Finding a side. Use the law of sines by setting up proportions based on the known angles and sides, and solve for the missing side. To summarize, understanding the configurations and correctly applying the law of sines allows you to solve oblique triangles effectively. Remember, each set of given elements opens a different path to the solution.